All right. So first thing we're going to do, what makes this a multi-step is that we're going to have to do something before we use the two-step approach that we did last time. In this case, we're going to combine like terms first. And so you really want to combine like terms first. This is something that a lot of students, they want to jump right into adding the 23 to each side, that type of thing. I mean, if you're looking at this and if you were to, some of you went ahead, maybe you did that. But what we want to do is collect like terms so you have one x term and one constant on one side of the equation. So if you look at these two here and here, we want to add the like terms first. And when I say add like terms, I mean on one side of the equation or the other, or both. This is not to be confused with the combining of like terms that happens when we do the inverse operation. We're just collecting the terms on one side. And what you wanted to make this look like is like the problems we did last time. So if I add the 5x and the 2x, I should talk a little bit about collecting like terms. The way you add 5x plus 2x is you add the numbers in front of the x's, the 5 and the 2, and that gives us 7, and then you attach the x. So like terms mean that they have the same variable attached to them to the same power, or they're a constant. A constant would mean just a number. So like terms, we might want to define that too. This is, or review it at least, but like terms are constants or terms with the same variable raised to the same power. So they're either constants are like terms, or they're the same variable raised to the same power. Okay. So you guys have seen this before. It looked like from the diagnostic you had, that was not an issue in the diagnostic. There was the fractions and the equation solving, but the combining like terms we seem to know how to do that. So might want to write that down just so you have a definition. So let's go ahead and add the like terms. 5x plus 2x is 7x minus 23 equals 5, and now I'm right back where I was on the two steppers, right? I have this x term plus or minus something. What do we do to each side first? I'm going to do here first. Add 23. So we have 7x equals 28. And then the second step is the division, yeah. So divide by 7 on each side, x equals 4. And here's where it gets difficult. I mean, you can check it in there. It starts to get more difficult to check it because you're plugging in multiple places. So just got to be careful as you go through. Big deal here, though, is being able to combine like terms. Why don't you try this one? Notice it's 11m minus 6m. Okay, the minus goes with the 6m, so you're going to subtract those two first. Go ahead and try that one. All right, so you should have gotten m equals 6. All right, so solving a multi-step equation, we're going to write an equation first and then solve it. So this one is, let's read it here. Martha takes her children to a concert. She buys shirts and decals for them. The decals cost $1 each. Her daughter wants 1 shirt and 4 decals. So you can see in bold here the things that are involved in the equation. Her son wants 2 shirts but no decals. If Martha spends $67, write an equation that represents her total purchase. How much does 1 shirt cost? So we're going to be solving for the cost of one shirt. So we've got on here, if we define our variable, let's go ahead and define our variable. Let x, or x can equal the cost of a shirt. So that's what we don't know. It says that the decals are $1 each. So if the decals are $1 each, we know that this value is what we call a constant. So the 4 is a constant. The shirt will be a 1 times x and a 2 times x. So it's going to look like this. If I take one shirt, it's a 1x plus 4, okay, because it's $4 for 4 decals, plus her son wants 2 shirts, that's 2x, and then no decals, so that would be a plus 0, and that gives you the $67. So that's what our equation looks like. If you kind of break it up into pieces, you've got shirts times their cost, and decals are $1 per decal. So first we'd combine these like terms. 1x and 2x is 3x, plus 4 equals 67. Subtract 4 from each side. So 3x equals 63. And then divide by 3. So x equals $21. So what that means is it's $21 per shirt. Alright, so we should have gotten x equals $14. Alright. This next equation adds another step in here. This is a distributive property. So distributive property says that if you have something like a times b plus c, that's equal to a times b plus a times c. In other words, you multiply the a by each of the terms that you see in parentheses. So we're going to do that now. I'm going to take negative 8 and multiply it by 2x. I'm going to go ahead and show what I'm doing here. Typically we would skip this step, but I'm going to show you what we're multiplying. So that, and then I have minus, and then it's negative 8 times 1 equals 36. Some students will think of this as plus and then put the negative sign with the 1. Either way is fine. When I multiply these two together, I get negative 16x. And then I have minus, negative 8 times 1 is negative 8, so minus and negative will change that to positive 8. So that's the second distribution, equals 36. And now we're right back at the two-steppers. So we'll subtract 8 from each side. Negative 16x equals 28. And then divide by negative 16 on each side. And so negative 28 over 16 is a fraction that can be reduced. It's an improper fraction, right? So it can be reduced. So 28 over 16, what does that reduce to if we start cutting it down, right? Cut it in half, it's 14 over 8, and 7 over 4, yeah. So negative 7 over 4, or negative 1 and 3/4. I saw some of you had already done it, and you had negative 1.75. That's correct. Negative 1.75. All right, why don't you try the next one on there? All right, it says, can you solve the above problem by dividing by 3 first? What do you think? Could we divide by 3 right here first? Would that work? Did anybody do that? Try that? Let's try it. So if I take 18 equals 2x minus 6, and I divide this whole thing by 3, and divide over here by 3. You look skeptical. Divide each side by 3. This will cancel the 3's here, leaving just 2x minus 6. 18 divided by 3 is 6. And if I add 6 to each side, I have 12 equals 2x. So by dividing each side by 3, right off the bat, I'm canceling out the 3, leaving just what's in parentheses. And then divide by 2 here. So x equals 6. So that worked. That's another option. Instead of distributing on these, you could divide first. That works because we have a product of 2 values here, this 3, and then the 2x minus 6. So it's not a problem to divide each side by 3. Works great. All right. One of the other objectives in here was to be able to solve equations with fractions in them. So multi-step equations, the extra step in this one is going to be clearing the fractions. So solving an equation that contains fractions. We have 3x over 4 minus 1x over 3 equals 10. There's a couple options here. One would be to get a common denominator. So I could get a common denominator. The other one is called clearing fractions, or finding that least common denominator and then using it to multiply each and every term by that number. So here's what it looks like. Let's call it the least LCD. So here's the process for finding the LCD, or least common denominator. You start with the bigger of the two bottoms. So we go with the 4. You ask yourself, does 3 go into 4 without a remainder? No, right? Then you take 4 and multiply it by 2, go up to 8. So we go from 4 to 8. Does 3 go into 8 without a remainder? No. So then I jump up to 4 times 3, which is 12. Does 3 go into 12? Yeah, so just taking the bigger of the two and then going up by multiples of that number until you find the first one that the other thing will go into. Okay, so the 3 will go into that. So 12 is my LCD. So here is one way to do this. It's called clearing fractions. I've seen it called fraction busters. Okay, fraction busters. So we're going to fraction bust here by multiplying through by 12. So we're going to multiply each term on both sides of the equation. So each and every term on both sides of the equation. The reason you have to do each and every term is because of the distributive property, and both sides of the equation because you have to keep it an equivalent equation. Okay? So what some students will do, at least more advanced students, I'm going to start you off with a little different, but I'll show you the first step that they would do. They would write the 12 here, and then in parentheses they'd have 3x over 4 minus 1x over 3 equals 10 in parentheses times 12. So, one of my pre-calculus students would probably do it like this, and then do the distribution in their head. I'm going to show you exactly what we're doing, okay? Because it gets confusing on the canceling when you're using that same term 12 twice to cancel. So here's what it looks like. It's 12 times 3x over 4 minus another 12 times 1x over 3 equals 10 times 12. So in the beginning, I would recommend that you go to this step where you just put whatever the LCD is, multiply it by each and every term, and show that step. You with me? I think if you show that step, because what we're going to do next, I'll do it in red here, is we're going to use this 12 to cancel or simplify here in both of these fractions. Okay, so 12 and 4, 4 goes into 12 3 times, right? And then here, 12 and 3, 3 goes into 12 4 times. And so what am I left with here? 3 times 3x is 9x. And 4 times 1x is 4x equals 120. So you see why we call it clearing the fractions or fraction buster. So we're getting rid of the fractions by multiplying through by the least common denominator. I think you'll find that easier than finding a common denominator. I could do it that way as well if you I can show you that way. So we have 5x equals 120. Divide by 5, divide by 5. I apologize, there's not quite enough room on there. Sorry about that. I noticed that as I was going through. Not quite enough room for all the steps I wanted to show. We have x equals, how many times is 5 going to 120? 24 times. So x equals 24. So that's called the method of clearing fractions. Let me show you what this would look like if we found a common denominator. So do that in red. If I had 3x over 4 and I want to get a 12 on the bottom here, I'd have to multiply top and bottom by 3. Right? So it would be 3 over 3. And then minus 1x over 4 times, or actually that was over 3. And I want a 12 on the bottom, so I multiply by 4 over 4. And then I would leave the 10 alone in this case. So what would happen here is I have 3x times 3 is 9x over 12 minus 4x over 12 equals 10. Since they're both over 12, I can think of this as 5x over 12 equals 10. So I'm just getting a common denominator. And then this is like the problems we did last time, where this is actually the one step. This goes back 2 lessons ago. We figured out a way to handle these fractions in front of the variable, right? With one step. Do you remember what to do? What do we do to each side to get rid of that fraction of 5 over 12?
Cross cancel.
We do. We cross cancel by multiplying by what? It's a special name. What's the... here, it's a reciprocal. Reciprocal. So I would take this and this and multiply it by the reciprocal of the 5/12, which is 12 over 5. So yeah, these cancel, leaving x equals, this cancels, becomes 2 and 1. 2 times 12 is 24, and look at that, the same thing. So there are 2 different methods of handling these fraction problems. One would be get common denominators, get it as a single fraction, multiply by the reciprocal, or clear the fractions out. Both work. It's your choice. So let's go ahead and try do the try one here. I'll come. Right, so it should be 60 over 23 for the try problem. You have 60 over 23. Just leave it like that. All right, solve an equation that contains decimals. So there will be some with decimals in it. You might want to use your calculator on this one. So if you have a calculator at home or have one with you, or if you want to borrow one of mine, you might need the calculator. I can do it without the calculator. We'll do it up here without. So here's how I think about this. Especially when it's in hundreds, it's like, think about money. That's probably the best way to understand this. I'm going to combine these 2 like terms. I'll circle them here and here. And so 3.5 is really like $3.50, right? And then 0.02, that's really like subtracting 2 cents. So when you start talking money, students usually get it. It's like $3.50, take away 2 pennies, and what do you have? Right, 348. You guys are all asleep still. So 348. So we got 348 right there when I combine the 2. Do you see why they're like terms? What makes them like terms? They both have an x. So I can combine them. I get 3.48x equals 1.24. And then when I went through and did this, I just left it here, but there's just one more step. Take the 3.48x, and I got to divide by 3.48. And the 1.24 and divide by 3.48. So I would be okay with you just leaving it like that on these ones. You just leave it x equals 1.24 over 3.48. If it's a real life sort of problem or something, you're asking for a percentage, what percentage that is, you're going to get a decimal to the nearest hundred. So let's do that. Let's get a decimal to the nearest hundred. Let's pretend this is a question where they're asking 1.24 is what percent of 3.48 or something. But what do you get to the nearest hundred? So 1.24 divided by 3.48. What do you guys get? Get it? What do you have? Yeah, that's what we have. So 0.35, and then there's a 6 after the 5, so we'll call it point. So it looks like this, 0.356, and it keeps going. But if I want it to the nearest hundred, because the 6 is bigger than 5, I would make this go up 1. So I'd get about 0.36 to the nearest hundredth. So do you know why I'm rounding to the nearest hundredth on this one? We talked about that in the science class. Like, what's the farthest out they go in the problem? 1.24, they go out 2 places past the decimal in the problem. So I'm rounding to the same place value. That's pretty common, okay? So we'll round to the nearest hundredth on that one. Why don't you, as your classwork, try this last decimal one, please? So try that one on your own. I'm going to come around and check and see if you got it. And we'll call it good on classwork today.